Hello everyone. So this is going to be the very first lecture of physics on this new channel of JEE English by me. So in this first lecture, I would not like to go deeply into the problem solving part of JEE, which we'll be covering in coming lectures. Here I would like you to introduce the subject physics itself. I would like to introduce the subject physics itself to you. So if anybody asks me what is physics, my answer always is this: it is the final logic of all science. The final logic of all sciences. Now when we say this, it begs the question, what is science? And not only that, whenever we talk of science, somehow or other mathematics always comes into being. Mathematics just tags along. You can't talk about science without maths actually. So what is the role of mathematics? So I like to discuss these questions. You may wonder what is the use, if you are studying for JEE, of all these theoretical ideas. It is just so you know the subject itself, because once you understand that subject is about this particular thing, it helps you build up the aptitude for the particular subject. So it is very important that I do introduce you what is physics, because JEE questions themselves and JEE itself, while making paper, remembers this, that it is about making the paper of physics, not just whatever is being taught in coaching. All right, it is more about that you understand the subject or not, and the best place to begin is the very beginning, that what is this subject about. So when I ask what is physics, I get many times these type of answers: study of nature. What is science? Scientific study of nature. These type of answers I have also received, that science is scientific study of nature and physics is study of nature. All these type of answers I have received, but I would like to stick to this answer, that physics is the final logic of all science. What does it mean? What does it mean when we say science? What is science itself? What is science? So let's talk about that. Now, to understand anything in life, there has to be dichotomy, that there has to be one side and the other side. So, to understand what is science, we also need to understand what is not exactly science. All right? So, we have a better clarity. Now, when I talk about what is science, most of the time the answer I get is essentially something related to logic, that whenever we are able to explain things logically, we say it is science. I completely disagree with this part. Logic is not the primary requirement for science. Yeah, I know when I say that, you must be wondering, this guy is definitely wrong. No, I would like to quote Richard Feynman. If you may have heard his name, his lectures on physics are world famous. They are considered the best lectures on physics for the college physics undergraduate starting level, which is basically same as India's 11th, 12th physics. For a deep understanding of physics, you don't need to study them. If you have spare time, you may. Otherwise, for teachers who want to teach good physics, that is the primary material where you do understand what is physics. So, going back, and Richard Feynman was also awarded Nobel Prize in physics, and he is considered the best physics teacher ever. And he was very good in explaining things. So, Richard Feynman used to say that however good your logic may be, however elegant your mathematics may be, But if your result do not match with experiment, your theory is useless. It is wrong. So please understand, science is not primarily about logic. Science is primarily about evidence. It has happened many times in science, especially in physics, that proper logic was not there, but based on evidence, we had to believe that this must be right. There are many instances like that. One instance that comes to my mind, because I was teaching it yesterday only, is a Bohr's atomic theory. If you may have heard it. So Niels Bohr gave some type of a jugaad type of a thing, which is quantization of angular momentum, which was necessarily just a hodgepodge thing. He couldn't explain why. But if you assume that to be true, you will find that all the experiments that were done before and all the predictions that Niels Bohr's theory was doing were coming true. Matlab, it was based on evidence. So something which is based on evidence, it becomes 100% accepted in the scientific community. It is not relegated based on the devoid of that it is not presently logically available. So many times some things are not logically available, but still scientists accept that if the evidence shows that this theory is working, even if the logic is not complete. Another example is neutrino. Neutrino were predicted that there must be a particle which is not interacting with matter based on evidence. There was no theory to suggest neutrino should be there. And it took many, many years for that. So it happens many times. In fact, another instance is the direct observation of charge as an electron was done in 1890s. But whole electromagnetism was developed by 1850s. So think about it. Because the evidence was suggesting that these equations are true. What is causing that electric field? That particular particle was discovered much later. So this is how science goes. Science is primarily based on evidence and a theory which can explain evidence. Even incomplete theory is okay. Okay? A theory which tries to explain. Tries to explain. Even incomplete theories have been accepted in physics. Even incomplete theories have been accepted in physics and science just because they were able to show that we are predicting such and such a thing if you do such and such a thing, and the results were coming quite close to the prediction. So let's talk a little bit more about this. So what are the primary ingredients of science? Let's go. It is basically measurable predictions. Measurable predictions. Like you have to predict something, that if I drop this pen in a vacuum, I'm predicting it would take so much time to fall. I'm predicting this is how its velocity will change. These are all predictions. And you can measure it, that if I told you it would take 1.34 seconds to fall from this particular height, and it takes 1.34 seconds, that means my science was correct, my theory seems to be okay, until and unless I do some finer experiments where I'm able to measure time to more precision, and then I have to check whether my theory is still working or not working, as is the case with the Newtonian gravitation and general theory of relativity given by Albert Einstein. Newtonian gravitation theory works unless you start measuring things to great precision. Then you see the difference comes. So these are the basic ideas. The idea is measurable prediction. That is what science is all about. And when we are talking about something which is not science also can make predictions, but generally they will not be measurable predictions. It may be something like this, that if you do something like this, you will go to hell in next life or after dying, or something like that. It is not measurable. So that is not science. It is something else. I'm not criticizing or saying anything in favor of that. All I'm saying that the prediction is not measurable. That if you do this sin, or if you do this good, you will get this or that in next life or after dying. It is not measurable. There is a prediction, there is a logic that if you do good, you should get good. If you do bad, you get good, bad. But it is not measurable. So science is about measurable predictions, and to predict. Now, to predict, you need a theory. How do you predict? Predictions, you need theory. And to be measurable, you need mathematics. This is how mathematics becomes part of science. How does mathematics becomes part of science? Because when you say you want to measure means there has to be numbers. Otherwise, how do you measure? Right? You have to measure, you have to observe. And when you observe something, you have to measure it in numbers. And to measure it in numbers, what you need is mathematics. You need data. Alright? If you say that it would fall faster in vacuum compared to in a room where there is air, you have to have measure, because faster itself is not good enough. Without measuring how fast, you can't say fast. To say faster, you should be able to measure, and measure would always means numbers. So that's why your theory should give some formulae in mathematical form also. Otherwise, that theory, sometimes you would find there are theories in physics which do not talk in terms of number, but they are very important. So we do consider them important theory, we do discuss them. There are laws like that. You may have heard of Lenz's law, which is very, very important in physics, but it generally does not talk in terms of number. It just essentially says that loop opposes the change of magnetic flux. Alright? So it's a law of physics. It is there. It is making a prediction, which is always true, but there are no numbers involved. But generally in science and physics, we would like laws and formulas which are in a mathematical format. So mathematics helps us measure different quantities. Alright? Because unless we measure in numbers, the prediction, we cannot tell how good our prediction is or how bad our prediction is. So for prediction to be good or bad, we need to know how close it is, what we have measured is to the prediction. For that, how good or how bad, we have to have numbers. Because we cannot talk like this in science that I hate brinjal 2.3 times more than bitter gourd. Alright? I can't say that. That is not meaningful at all. Right? So in science, we need to have predictions and measurement. Wherever you do that, that is science. Another example would be like when this corona thing was going on, there were vaccines coming, and they were saying that this particular vaccine has this much efficacy. They used to talk about efficacy of vaccines. So it was in terms of numbers. Just doctors are scientists, practicing scientists essentially. So they would always prescribe things in number, that for this particular weight, if you are having this much size and this, doctor would say, okay, you take this much medicine. Especially if you go to a pediatric, because based on how young child is or how old child is, the doses they need to vary according to the what is the blood pressure or this or that. They vary the amount of drugs. So that is again numbers. So science would be always in numbers. However beautiful philosophy you read, if that philosophy is not talking in terms of numbers, it is not science. Science is predictions which are measurable, that is numbers, formula, equations. This is what science would be always about. Okay? Now, let's go back. What is physics? So, what is physics? When we talk about science, what does it involve? It involves chemistry, it involves biology, it involves physics, it involves medical science, biochemistry, all these things, all right, pharmaceuticals. These are all hard sciences, all right? Computer science, electronics, these are applied sciences where you apply what you learn in science to more direct use. Electronics, mechanical engineering, civil engineering, all these things are, you are applying science directly to the world to produce gadgets, etc. These are all applied sciences, right? Now, where does physics fit in? So, to understand this, if we make the logical sequence, for example, medical, the field of medical, medicine, biology, right? Like for medicine, to study medicine, you should know biology, right? Biology would form basis of medicine. And obviously, some chemistry to support that. But if you go deep into biology, that why something is happening, what is happening, they will ultimately start talking about protein this, protein that, this does that. They will start talking about that, which would be essentially biochemistry, which is based on organic chemistry, which is based on fundamental of chemistry, bonds, etc. And which chemistry itself, all right, is based on the laws by which atoms combine, the existence of atom itself, molecules, that is physics. Now, if you go beyond physics, there is nothing there. When we go to atoms and how atoms interact with each other, that becomes chemistry. But atom itself, why it needs to interact, the quantum mechanics of that, that is the last part. There is nothing below that. This is the end. That's it. You cannot go and ask what is the logic of quantum mechanics. They will say these are the rules of quantum mechanics. Atoms follow them and you can check them in this experiment. This laws can be verified, checked in a particular experiment. But you can never go and say what is the logic behind this law of physics. The law of physics itself is the logic put in English or in a mathematical format for you to understand and to apply. So when you talk about laws of physics, you should not discuss most of the time what is the logic behind them. If in physics we give name to something as a law, it is considered full and final statement. Yeah, if you go a little bit deep physics, then you may find something fundamental, more fundamental to that. But for our purpose right there, this is it. But when you study physics, you must inquire that is it actually a law or somebody is just saying it's a law so you can solve questions. It's just a technique. Because if you study physics by just learning techniques to solve problems, there would be a big problem because that technique may or may not work. Now you understand why I was talking about what is physics? So you understand clearly that when you're studying physics, are you studying laws of physics or problem solving techniques? Sometimes we study techniques of problem solving in the name of concept as a law. No. They are not law. They are just, if you, in particular scenario, if you do these steps, you will get your answer. But if you change scenario a little bit, it may or may not work. That's why it is very, very important while studying physics to understand, are you studying a so-called concept, which is basically a problem solving technique, or is it a law of physics? Because law of physics is the final thing. You can see whole medicine would fall if law of physics is different. If atoms start behaving differently, nothing in medicine, we will not survive, ourselves will not survive. Alright? So that's why I thought let's start with the first thing. What is physics? What is science? What is maths? So to recap, what is science? Science is basically you are doing measurable predictions. That's why you need experiments. That's why experiments are so very important to the scientists, that they spend billions of dollars building LEGO, if you may have heard about it, LEGO, alright, Light Interferometer, Gravitational Observatory, or James Webb Telescope. Recently they sent it, NASA, alright. That's why they spend billions of dollars, because they are the experiments to measure, and as you go on measuring finer details, you would need more experiments and you have to spend more money to get finer things. But it has to be measurable. You can't do predictions which are not measurable, that these people were doing a lot of sin. That's why inundation came and people died, or some natural calamity happened because people were doing sin. That doesn't work in science. It may be true or false, that's a different thing, but that is not science. Science is about measuring your predictions. And to measure, you need to put some part of your theory in terms of some formula or mathematics. And to do this, you would need strong mathematics, so you can do all the calculations and you can do the measurement part and check that whether your measurements are same as predicted. That's why this is all thing about science. But when we come to the final logic, that whatever we are predicting, so we are creating new theories. So when you come to the theory, and the fundamental theory that beyond which you cannot go would be physics. For example, right now I am teaching, this lecture is being recorded in a AC room. Now think about air conditioning. Air conditioning is a very good example of how laws of physics and practicality work. Laws of physics state that ultimately whatever machine you operate, you will heat something. Heat would be there, right? In another word, it is second law of thermodynamics, that entropy of an acid system must increase. Then how this AC is cooling this room? By producing more heat outside than how much it is cooling inside. So net entropy is increasing by the operation of this AC. So you see, the laws of physics says you must generate heat, but still you are able to cool by generating more heat outside than you are cooling inside. So this is how laws of physics and the practical side works. And I hope you understand that why you need to study laws of physics and differentiate between what is the law of physics and what is not law of physics. Thank you.